Hi, today we are going to see data structure. So what do you mean by data structure? Before we are going to see the definition of data structure, so I want to tell you what is data structure. So data structure, there are two words are there, one is data, another one is structure. What do you mean by data? Data, it is nothing but a information. We already known that as a computer science student. What do you mean by structure? Structure, it is nothing but some kind of arrangement. What kind of arrangement? There are several kinds of arrangements is there. We are going to see in detail in the succeeding videos. What do you mean by data structure? Means the data which is arranged several kinds of arrangement, and through that arrangement only we are able to use the data effectively. Okay. So what is the definition of data structure? A data structure is basically a group of data elements that are put together under one name and which defines a particular way of storing and organizing data in a computer so that it can be used efficiently. So this is what the definition of data structure. Suppose I want to tell you some live example. So we are going to see two live examples now. One is I want to find it out a particular height of a particular student in the class. Just you imagine that there are 60 students are in the class, and I want to find it out some 5.3 height fellow in the class. Okay, how can I find it out? The students are sitting from the first bench to last bench. So suppose there are 12 rows are there. There are three compartments are there. These 60 students are sitting like a way, and at the time of sitting in the class, they are not sitting in any arrangement. According to their friendship, they are sitting accordingly. Okay, how can I find it out? 5.3 fellow means the only one way we are able to find it out is we are calling each and every student from the first bench and we want to make a measurement with a tape. That is the only possibility. How many measurements I want to take? It is exactly 60 measurements we need. Whether it is exactly 60 or it may less than 60. For example, that particular student 5.3 height fellow who is sitting in the first bench itself means maybe after measuring 4 measurements I may find it out that particular student. Whenever I find the student, I stop the process. Okay, I don't want any other measurements. I got a result. Okay, that's why I stop the process. Suppose I am measuring 3-4 rows. After fourth row, the student may be sitting in the fifth row, and exactly 5.3 I got it up in the fifth row. Then I stop the process. So here the number of measurements is maybe it is 27 measurements. Okay, suppose the student which is the 5.3 height fellow, who is sitting in the last bench, how many measurements I want to take? Means I want to take at least 50 plus measurements. Okay, so suppose the student strength is 60 at the maximum 60 measurements we have to do. Suppose the student strength is 100 means how many measurements we need? It is 100 measurements. At the worst case it is 100 measurements. Best case is also there. Maybe unfortunately the student is sitting as a first student, so luckily we are getting within a single measurement I am getting the result, but I am unable to sure that that student first student may be the 5.3 fellow. Okay, so this is totally probability. Okay, so now I want to reduce the number of measurements. In this case, what I do? So one method is there. That method it is called before making the measurement, I want to arrange one line according to the height wise order of this particular class students. So what I do, the shortest fellow may stand front and the tallest fellow may go last, and according to their eyesight capacity they are forming one line, and after forming one line, so according to my own eyesight capacity I am able to find it out 5.3 in between. So I am taking 3 or 4 students in between the line and I make a measurement. Automatically I have to find it out the result within 4 measurements. At the maximum within 4 measurements I am able to find it out the data. And now you tell me what is the difference between these two? The first one, it is nothing but the first one data which is not yet arranged according to height wise order. They are arranged, but they are not arranged in a height wise order. Whereas in the second case, we are arranging the students in a height wise order. Before I am taking the particular height, I am finding the particular height fellow. So this is the difference between these two. So the first one, it is not a data structure. The second one, it is called a data structure. The data which is arranged in a height wise order structure. Okay, this is one example. The other example I want to tell you, the other example is, suppose I am giving you 10 color pencils with the three different colors pencils to you. What you do means, I want to find it out a particular color among the 10 color pencils. Maybe the colors are red, green and black. Okay, suppose I want to take red color pens only. What I do means, I am able to take it up within the 100 pen it very easily. Suppose you imagine that instead of 10 pencil, I am giving you 100 pencil with the 3 colors. Instead of 100 pencil, I am giving you 1000 pencils in color, three different colors. Instead of 1000 pencil, I am giving you 10,000. I am giving you 1 lakh pencils. So how can you arrange it? So what is the method we follow means, we have to segregate the pencils according to the color, then only we are able to take the particular color when I want the particular color from the color pencils. Okay, so before I am taking a particular color, I have to divide the pencils into color wise group. Okay, so this is, we call it as data structure, another example of data structure. Okay, now the most common data structure operations are, these are all the most common operations which is held in the data structure. The first one is traversal. Traversal, it is nothing but, suppose we want to find it out any data through traversal. Traversal, it is nothing but traversing. When just we are taking the previous example, suppose I want to find it out 5.2 fellow, what I am doing means, I am going student by student, one student, second student, third student, fourth student, like that. So this type of going student by student, it is called a traversal, traversing one by one. Then insertion. What is insertion? In our second example, what we do means, we are taking 3 color pencils and we are segregating the pencils according to color. So that is, we are inserting one color in one box, we are inserting other color in other box, we are putting other color in the third box. So this is, we call it as inserting. Then deleting means, suppose I want to take one pencil from that existing number of pencils, that is, we call it as deletion. We are taking one out and the already it is 5 pencils are there, now it is only 4 is there, one it is taken, one it is deleted. Then what is it? Searching. Searching, it is nothing but, we are searching the 5.2 height fellow. At the time of searching the 5.2, we are following 2 methods. First method is, without arranging the students in height wise order, we are taking bench wise order. Okay, whereas in the second case, we are forming one line according to height wise order, then we are point out 4 or 5 students and we make a measurement and we are finding the result. This is, we call it as searching a particular data among the set of data which is given. Then sorting, just now I told you, sorting in the first case, they are forming one line according to height wise order. This is, we call it as sorting. And in the pencil case, we are sorting according to the color wise order, we are grouping together. So this is, we call it as sorting. Merging, it is nothing but, we are after our process is over, hereafter I am not doing any process in the particular pencil, then we merge together and we are keeping in the single bag. Okay, then copying, it is nothing but, just we are take one copy of information from the existing one. So these are all the important data structure operations which is frequently held in the data structure subject.
Thank you.